Hello everyone, in this video we will cover the geometric series test. This is one of the important and the most easiest tests to check whether an infinite series converges or diverges. So let's understand the concept of this. First thing is, what is a geometric series? So when we say geometric series, there is a two things. One is called series, one is called sequence. Sequence is just the terms separated by comma. Like if I want to write the same thing in the sequence, it is ar square, ar cube. This is known as a sequence, and when we replace the comma with the plus sign, that becomes a series, or you can say sum of the terms of the sequence is called a series. So geometric series is in this form. So here if you say one example, you can see that this is a. Second term we are getting by multiplying the first term by some number. Third term we are getting again multiplying by r. Here also we are multiplying by r. Here also we are multiplying by r. So every next term we are getting by multiplying by something. So that number by which we are multiplying to get the next term, that is known as the common ratio, and a is known as the first term. For example, if you see, let's say if I'm saying 2 and next term I'm writing 6, next term I'm writing 18, next is 54 and then 162. So here you can see this is 2. How we are getting the next term? By multiplying it by 3, we got 6. Then again multiply by 3, we got 18. Again multiply by 3, we got 54. Again multiply by 3, we got 162. So this is known as a geometric series. And here how to get the common ratio? Common ratio we can get by dividing the term by its previous term. Like 6 divided by 2, that is 3. Or you can also say 18 divided by 6, that is also 3. The nth term for this geometric series is given by this. an is equal to ar to the power of n minus 1. And how we are getting this also? You can clearly see the pattern. If I'm saying the first term is a, second term is a times r, third term is a times r square, fourth term is a r times r power 3, fifth term is a r power 4. So if you observe, if it is 2, it is r power 1. If it is 3, it is 2. If it is 4, it is 3. If it is 5, it is 4. So exponent of r is 1 less than that. So in the same way, if I write an, it is a r to the power of n minus 1. That is the general term of the geometric series. Now, next thing, what is the geometric series test? How we can figure out whether the particular infinite geometric series converges or diverges? So geometric series will be written in this format, like sigma a r to the power of n, and n goes from 0 to infinity. Now there are two things. When the absolute value of r, the common ratio, when the absolute value of r is less than 1, then we say the series converges. And if the absolute value of r is greater than or equal to 1, we say the series diverges. So when we are saying absolute value of r is less than 1, it means r should lie between minus 1 and plus 1. And the meaning of absolute value of r greater than or equal to 1 means r is greater than or equal to 1 or r is less than or equal to minus 1. If it is following this condition, then it diverges, otherwise it converges. So diverging and converging means the sum of the terms will become infinity, then we say diverges. And if the sum of the terms like goes toward a particular number or the terms decreases, we say it converges. Just like suppose if I'm writing one of the series 2, then next one I'm writing 1, then 1 by 2, then 1 by 4, then 1 by 8, then 1 by 16, and so on till infinity. So here you can clearly see that the terms are getting decreased. What is the common ratio over here by which we are multiplying to get the next thing? We are multiplying it by 1 by 2. So common ratio is 1 by 2. So we can simply say, since 1 by 2 lies between minus 1 and plus 1, so therefore the series converges, because the terms are getting smaller, the sum will become finite. On the other hand, if I take like this, let's say 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 till infinity. Here you can clearly see that the common ratio by which we are multiplying to get the next thing, it's 4 divided by 2 is 2, or 8 divided by 4, that is also 2. So since 2 is greater than or equal to 1, common ratio is greater than or equal to 1, so therefore it diverges. because as you can see the terms are getting larger and larger. So if you add all of them, the sum will also become infinity. So we will say the series diverges. Now why it converges when r is less than or equal to 1? So there is one formula for sum of n terms of a geometric series is given by a r to the power of n minus 1 upon r minus 1, or sometimes in some books it is written like this, 1 minus r to the power of n upon 1 minus r. Generally we use this r when r is greater than 1, and when we use this when r is less than 1. So if the r is between minus 1 and 1, since r is lying between minus 1 and 1, so let us say r is 0.1. So what will happen to the r power 2? It's 0.01. Right. If I say r power 3, it's 0.001. So you can see as we are increasing the power of r, the value of r becomes smaller and smaller. So therefore we can say if r to the power of n, we will say r to the power of n will go towards 0 as n goes toward infinity. If you increase the power of r to infinity, it will go towards 0. So since the terms will go towards 0, this r will go towards 0, the term will getting smaller and smaller. So that's why the series approaches a finite value. And how we can find the sum? We can find the sum like this. Since we know sum of n terms is a 1 minus r to the power of n upon 1 minus r, as since if I am saying absolute value of r is less than 1 and r power n goes towards 0 as n goes toward infinity. When the n is going toward infinity, so r power n is going towards 0. So therefore the sum of infinite terms will be r power n will become 0 upon 1 minus r. So sum of infinite terms is a upon 1 minus r. So after knowing that the series converges, we can also find what is the sum to which it converges. So this is the formula, which is a upon 1 minus r, but this formula is only valid when the absolute value of r is less than 1. Absolute value of r less than 1 means r should lie between minus 1 and plus 1, otherwise it will diverge. And for the diverging, the sum is infinity also. So let us take the questions. So this is a series given to us. We want to find what is the sum of the series, and we will also find if it converges, we will also find the sum. So let's write it in this form. This is written 1 over 8 and minus pi power n. If you observe, compare with this, a r to the power of n goes from 0 to infinity. So r, what is r over here? You can clearly see that r is minus pi, and minus pi is less than or equal to minus 1, right? Because on the number line you can see minus 1 here, plus 1 here. Minus pi is what? Minus 3.14. It will lie somewhere over here. So since minus pi is less than or equal to minus 1, so therefore simply we will say the series diverges. Simple. Similarly, let's take another one. Here it is done 2 power n times 3 power minus n. So we have to convert into a suitable form, and here n starts from the 4 to infinity. So this is 2 power n. 3 power minus n using law of exponent can be written as 1 upon 3 power n. Now we can also say it is 2 by 3 whole power of n, and this is 1 over here, and n goes from 1 to infinity. So now what is the first term over here? First term is on, it's not like this number is always the first term. First term you will be getting on putting n as 4. If you put n as 4 over here, so 2 upon 3 power 4 is the first term. But what is r over here? R is 2 by 3, which is less than 1. So therefore it converges. And since it converges, we can also find the sum of infinite terms. What we can say? We can also write like this. If you put n as 4, so the first term is 2 by 3 whole power 4. Second term is 2 by 3 whole power 5, 2 by 3 whole power 6, and so on. It is going to infinity. So sum of the infinite terms we can say a upon 1 minus r. So a is this upon 1 minus common ratio. Common ratio was 2 by 3. So it's 2 by 3 whole power 4 divided by 1 minus 2 by 3 is 1 by 3. So finally it is 2 power 4 divided by 3 power 4 divided by 1 by 3. So it will become 3 by 1. So finally we can say it is 2 power 4 by 3 power 3. That is the sum to which the series will converge. Let's look at this. Again, we have to first convert into the suitable form. in the suitable form we can say this is 1 minus 3 and this is 4 power 2n. So we can say 4 power 2 and whole power of n we can write divided by this is 5 power n multiplied by 5 power minus 1 we can say. Now this is n goes from 0 to infinity. So this is 5 power minus 1. The 5 power minus 1 will go in the numerator. So it will become 5, 1 minus 3 and this is 4 square is what? 16. 16 power n and then whole divided by 5 power n. Now this 5 power n we can distribute in both of them. So we can say 1 divided by 5 power n. It is like this and 3 as it is. And 16 power n divided by 5 power n, we can say 16 by 5 whole power of n. That is how we can convert. N goes from 0 to infinity. Now it is also looking like a geometric series. Now here this is the two geometric series actually. If you distribute the sigma over here, it is like this: 5 times 1 by 5 whole power n goes from 0 to infinity minus sigma 3 times 16 by 5 whole power n and goes towards 0 to infinity. So in the first case, in the first one, what is the common ratio? Here the common ratio is 1 by 5 and in the second case the common ratio is 16 by 5. So due to the common ratio of 16 by 5 we can clearly say that it diverges. So this diverges and this converges, but one of them is diverging, another one is converging, so addition or subtraction will finally diverge. If both of them converges, then we can say sum or difference will converge, but if one of them is diverging, then either the sum or the difference or both of them diverges, the sum or difference will be diverging. Let's see this. Here also we have to convert into the suitable form. So in the suitable form we can write it as this is 5 and we can say this is 3 power 1 divided by 3 power 2n. Now 5 times 3 is 15 and this is 3 power 2 and we can say 9 power n, 3 power 2 is 9 and we can also say it is 15 times 1 by 9 whole power of n. Now we can say it is in the standard format of the geometric series. What is the common ratio? 1 by 9. 1 by 9 is less than 1, so therefore we can say it converges, and since it converges we can find the sum also. The sum of the infinite terms we can find. What is the first term over here? So first term means like if you put n as 1, so if you put n as 1 over here, so 15 times 1 by 9, then 15 times 1 by 9 square and so on. So sum of the infinite term means a divided by 1 minus r. R is what? 1 by 9. So it's 15 by 9. 1 minus 1 by 9 is 8 over 9. So 8 over 9 will get reciprocal. It will become 9 over 8. So 15 by 8 is the sum of the infinite terms over here. So this converges basically. Let's see next one also. Here we can say 6 power n can be distributed in both of them. So it is 5 by 6 whole power of n and this is 2 by 6 whole power of n. So in this case you can see both of them, the first one and the second one, both the common ratio are less than 1. So both the common ratios are less than 1. So finally we can say both of them converges. So sum will be converging. Now we can find the sum also. So we can say it is 5 by 6 power n and sigma 2 by 6 power n, and goes from 1 to infinity and goes from 1 to infinity. So if you write the terms for this, it is 5 by 6 plus 5 by 6 power 2 and so on. Second one will be if you put n as 1. So 2 upon 6 I am writing 1 by 3. 1 by 3 plus 1 by 3 whole square, and till infinity it is going. This is also going till infinity. So we can find the individual sum. So for the first one it is a divided by 1 minus 5 by 6. 5 by 6 is the common ratio. Plus here it is a divided by 1 minus r is common ratio 1 by 3. So here we can say 5 by 6. 1 minus 5 by 6 is minus 5 which is 1 by 6. It will get reciprocal. It will become 6 by 1. Here 1 minus 1 by 3 is 2 by 3. So 2 by 3 will get reciprocal. It will become 3 by 2. So 3 cancel, 6 cancel, so it is 5 plus 1 by 2, that going to be 11 by 2. So it converges and the sum is 11 by 2. So I hope you have understood this thing, how we are using the geometric series test to check whether it is converges or whether it is diverges. It is one of the easiest tests in the convergence and divergence of the series. Thank you for watching this.